day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Moses Maudu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. So today we're going to be looking at the topic that is in paper 2, which is circles, angles, and angular movement. And this topic has got the following objectives. So today's lesson will have the following objectives. So the aim of this lesson today is that we need to know how to define the mathematical terms. In other words, we must understand what is a diameter. We need to understand what is a chord, what is an arc, and those are terminologies that are used in circles. What is a central angle? What is an inscribed angle? So all this we need to know. Number 2, we need to understand and be able to convert angles to degrees and angles in degrees to radians and vice versa. So we really need to understand this, because this question comes every year. Find the area of the segment by using the area of the sector and also the area of a triangle. That you must also know. Find the relationship between the diameter of the circle, the chord, and the height. And you'll see when we do the formulae that this formulae are also given there, so you need to also know that. Determine the angular velocity and the circumferential velocity, of which our circumferential velocity there is also known as the peripheral velocity. Calculate the area of the irregular polygon. So this is one of the questions that also comes in each and every paper. We really need to understand how to do that. Now, what do we need to know here? The parts of the circle. That's one thing that we need to know. We need to understand, as I said, what is a diameter, what is the arc of the circle, what is a sector, what is a segment. All this we need to understand that. The topic there is 30 plus minus 35 marks. That includes the measurement. Okay, so which we're not going to look at today, but we are going to look at all other concepts here. Angular and circumferential velocity, angles and arcs, we're going to do questions on that. Sectors and segments, we're going to get the area of sectors. How to change from degrees to radians and radians to degrees. And this is what we're going to be doing using the activities that comes. Now, the formulae are there in the formula sheet. So I think it's page 2 of the formula sheet most of the time. So you'll find this formula as they are here. So the first formula there is the angular velocity. So the angular velocity is represented by that sign there, which looks like a W, which is called an omega sign. Now, the angular velocity is 2 pi n, or we can write this 360 degrees multiplied by n, where n is the rotational frequency. You can see how they write the formula. So in other words, you'll understand that, okay, if I'm given the rotational frequency or revolutions, other word for that will be revolutions. So I just need to calculate this, because the 2 pi, you can use it from your calculator. So 2 pi, in the next slide, you'll see how we work out the radians and the degrees. The next formula is circumferential velocity, which is denoted by the letter V. They tell you there that D there stands for the diameter, okay? And the N still stands for the rotational frequency. So what should be given for you to get the circumferential velocity? It will be your diameter and your number of rotation. So in other words, the rotational frequency. So if I'm given the N and the D, I can do that. Sometimes in this question, they give you the R, which is the radius. So if I'm given the radius, I know that the radius, how do I get the diameter from the radius? So the diameter, your diameter will be twice the radius. So in other words, it's 2 times R. If I'm given the R, to get the diameter, I must get it. If I'm given D, I need the R, then I need to divide. In this one there, remember it's a small letter s, which is S equals to R multiplied by theta. The very important thing here is this. So the R is the radius. This is the formula for finding the arc length. So if you are requested to calculate the arc length, that is the formula. So R is the radius. So if I'm given the diameter, I just divide it by 2. Theta is the central angle in radians. Remember, whatever is given as the theta will be given as radians. So if you are given a degree, then it means that you must change it to radians. Okay, so that theta is in radians, it's not in degrees. So we'll do a question based on this one. The area of the sector, we've got two formulae there. When do I use these two formulae? I'll use this formula when I'm given this, the arc length. If I'm not given the arc length, I'm given the angle, then I'll use this formula. So this formula is when I'm given the area. So remember again, this is the central angle in radians, not in degrees. If it's given in degrees, change it. Now you can see that this formula, these two formulae are the same. Because if I take this S and I say the S is the same as R multiplied by theta over 2. So I'll get R times R is R squared theta all over 2, of which I get this other formula. So you can see these two formulae are the same. It's just that if I'm given the arc length and the radius, I can get the area. If I'm given the angle and the radius, I can then still get the area of that using changing the degree into radians. All right, the other formula is that relationship. Remember the relationship between the height of the segment, the diameter of the circle, the length of the chord. So this is where you're given, so you'll be given two things here. So because I've got the height, I've got the diameter, I've got the length of the chord. So I'll be given two of those, then from there I must get the third one. So mostly you'll be given, most of the time you find that the height is given, so check which height they're talking about, because we've got the measure one, the height in the major segment and the height in the minor segment. Right, when you do that, I'll show you that part. So here, what is this formula for? This formula is for finding the area of an irregular shape. So in other words, if I've got an irregular shape, for instance, I've got something like this, and it's got sectors here and all that, and sectors there. I need to then calculate. So the A stands for the equal parts, and that part here is the ordinate, and the N stands for the number of ordinates that we are having. So if I've got 1, 2, 3, 4 ordinates, so in other words, I'll put only 4 ordinates. So the first one, O1 plus ON, so the first and the last divided by 2, and the second one, the third one, the fourth one. So I can stop at the fourth one if I've got 4 of them. If I've got 6 of them, I'll then continue with it. Okay, so you must understand this formula. You must always work with this formula when you're doing this section, right? And we've got the other formula for the area, which uses the midpoint. Okay, so please make sure that you also understand that one. Quickly, some pre-knowledge that we need to know here. The arc measure of the central angle. So here we're talking about central angle of the entire 360 and the radian measure of that angle. So you can see that the 360 degrees, if I'm talking radians, it will be 2 pi. So 2 pi is the same as 360 degrees. Now, in the first block there, I've got 360 degrees equals to 2 pi. If I divide both sides by 2, I'll get pi is equals to 180. So pi is equals to 180 degrees. The pi is the radian, and 180 is in degrees. If I divide by 4 on both sides, I'll get pi is 90 degrees is pi over 2. If I divide both sides by 360, I'll get 1 degree equals to pi over 180. If I divide both sides by 2 pi, I'll get 180 degrees all over pi. So this is in degrees. Okay. So if I want to convert, this is very, very important. Everyone must get these questions, because these questions, in a question paper, you find that there are 2 or 3 questions that ask you to change from degrees to radians and radians to degrees. So in this case, if I want from radian to degrees, I multiply by 180 degrees divided by pi. What is it that I want to eliminate? I want to eliminate my pi there. So if I've got 2 pi, for instance, 2 pi, I want to eliminate my pi so that I get the degrees. So that will be 360 degrees. Let me see. So I know that 2 pi is 360 degrees. If I want to eliminate degrees, for instance, if I've got 90 degrees here, in other words, I want to eliminate degrees. This one goes once, this one goes 2 times. So then I'll have pi over 2. Can you see this? Pi over 2. So this one is in radians. So this is radians. So the radians, if I want to remove the degrees, then I multiply by pi over 180. If I want to remove the radians, I'll multiply by 180 degrees over pi. So this is degrees, this is a pi. So I'm going radian to, so this one should be degree to radian. Okay, right? So if I want to convert that degrees to radians, then I'm going to multiply by pi over 180. So this you have to know. All right. Here's a quick question here. 225 degrees. How do I convert? This is in degrees. How do I convert it to radians? So now I want to remove the degrees. I don't want the degrees. So I'm going to say 225 degrees multiply by. So what is it that I should multiply by? I want to eradicate the degrees, so I'm going to divide by the degrees because I need it in radians. Okay, so my answer will be, so if I use my calculator there, that will be 5 over 4 pi. Right? So now I'll have 5 over 4 pi, but I can also write it in decimals. So I can just say 5 divided by 4 multiplied by pi, go to decimal. Then with my decimal, I'll get 3.92. Then I must write this, I must write the radians. Right, okay, which is short for radians. So in other words, 225 degrees will give me 3.92 radians. So you can see, I wanted to eliminate the degrees, so I must divide by the degrees. Look at the second one. Now with the second one, I've got 4 pi over 3. I want to change it to degrees. So it's in radians. So I'll have 4 pi over 3. What do I want to eliminate? I want to eliminate that. So I'll multiply by 180. I need the degrees now. Okay, so I know the pi and the pi will cancel out. Then from there, I work that one out using my calculator. 4 over 3 multiplied by 180 degrees, and that will give me 240 degrees. So you can see I've changed the radians to degrees, and now I can be able to swap them around to do them, to do both of them, degrees to radians and radians to degrees. So please, let's practice that. You'll see in the next question is the same principle that we're going to be using. Now, the terminology of the circle, quickly. So we know if I've got a line that touches one point there, this angle here, sorry, that point here, only one point there on that line that touches the circle. So that point, that thing there, that line there is called a tangent to a circle. This part here is a segment. So how do I get a segment? It must be formed when we draw a chord. You see, there's a chord, is a line that does not pass through the center of the circle. Once that chord passes through the center of the circle, then that chord is now called a diameter. So if I take that chord and move it and it passes through the center, then it changes its name. It becomes a diameter. Now a secant is a line that touches that circle at two parts. So can you see a tangent touches it at one point? This one touches that at 2 points. Okay, so that is a, and it extends. See, the chord is also touching there, but it stops there. But the secant will extend on both sides. You see, it will extend. So that's a secant. Now, the radius is the line from the center of the circle to the circle. So the radius is this line here. So here I've got this radius. I've got this radius here. I've got that radius there. So I've got three of them. But this radius and that radius, if it's a straight line, it forms a diameter. So we can't say this one forms a diameter because we've got two radii. No, it doesn't. Okay, so that one will not form a diameter. The diameter is a straight line, so it's a straight line that goes there. So we have that as the diameter, that one is the radius, and this one here is the radius. Okay, two radii forms a diameter. Now this part here is a sector. So what is a sector? Is this area that is formed between two radii, and they form what we call a central angle. So the central angle, it's formed when we have that radius and that radius there. So the radius, the angle between the two radii will be a central angle. And then the area that is formed there is called a sector. So you must differentiate between a sector and a segment. A segment is formed when we have a chord dividing the circle into two parts. So we have got a minor segment, and the whole thing there becomes the major segment. So the minor one is the small one there. Then the major segment is that big yellow part, which is the major segment. Now the arc is then formed here. So can you see that is an arc? So the arc is formed there when we have those two lines there forming an arc. So see there we have an arc. Okay, so I can draw lines in there and line there, so that one is forming an arc. Okay, so what we're going to be looking at also in the next questions will be the arc length. What is the length of this part here? What is the length of that part? And these questions are also there in the next one. So now let's move on to the questions, the activities now. Now we're going to talk now circles and arcs. So you see we have a circle, we have an arc. So here is an arc. Remember, this is an arc now. So the arc there does not have any, the length is x, we don't have any value there. But we know that the radius of that will be 9. So if this line is 9, what will be the length of that line? The length of that line will also be 9 because it's also a radius. What is this angle here? It's a central angle. We're going to call it theta. Now, the first question here says convert 54 degrees to radians. Can you see? And that question comes every year. So what do we do? We're going to then do 54 degrees multiply by, what do we want to eliminate? Degrees. So we're going to divide by degrees. If I want to eliminate degrees, I divide by the degrees. On top, it's pi. It's radians. So now I'm going to have 54 multiply by that. So I'm going to then get, I can either write the answer as 3 over 10 pi. Okay, right? Or I can write in decimal, which is going to be 0.94 radians. So remember that I want to change that to radians, so I must write the units there, which is radians. It's not degrees, it's radians. So 0.94 is radians. In the next question, it says calculate the length of arc x to the nearest whole number. Very, very important that you also read the question and understand that, to the nearest whole number. So what do I need here? I need the length of this line. I already know that this one is 9 centimeters. Then you go to your formula sheet. In the formula sheet, the formula will be there. We need the arc length. So arc length is denoted by small letter s, r multiplied by theta. But remember, the theta is in radians. So which means I must then go back and check how am I going to. Do you remember the equation in A says change 54 degrees to radians? So already my theta now, I know what is the value of theta in radians. But in some question papers, you'll find that you are only given that degree as 54. What is the first thing that you need to do? Change it to radians. Then you can then substitute. So in this case, it's already done for me. So the radius, I know it's 9. I'm multiplying it by 0.94 radians. I know it's in radians now. If it's not in radians, I must then change it to radians. Okay, so now I'm going to multiply that. So the answer that I'm going to get here will be 27 over 10, I think. 27 over 10 pi, or 8,48. So remember, this is in centimeters because the length there is in centimeters. So what do I need then? The question says to the nearest whole number. So to the nearest whole number there, this is 8,5. So 8,5 will give us 9 centimeters. So to the nearest there, it will be approximately 9 centimeters. Okay. So it's very important that obviously you're going to get a mark for the formula, a mark for the substitution, and a last mark for that. So remember, this is very, very, very important that you know that you read the question and understand, because if you leave it there, you're not going to get a mark because the question is clear to the nearest whole number. What are we testing? We're testing if you understand how to round off to the nearest whole number. Okay, right. Now, the next question here says calculate the perimeter. Sometimes these questions are a challenge because we don't understand the terminology that is being used, but we know what to do. I already know that this side here is going to be 9. It's going to be 8,48. This side here is 9 centimeters. Right. So now I need the perimeter of the shaded region, which is the sector. So I just need the perimeter. Question is now, do you know what is the perimeter? You see, and that's where the problem lies. Sometimes we are able to do these questions, but we don't understand what the question wants. So in this case, what is perimeter? Perimeter, so I've got that side and that side and that side, and I add them together. Then I get the perimeter of that area, of that part. So the part of the shaded part. So the perimeter is going to be, my perimeter is going to be the 9 centimeter plus the 9 centimeter plus the 8,48. So I add all the sides. So perimeter means I must add all the sides of that figure. So in this case, I'll have 9 centimeter plus 9 centimeter plus 8,48 centimeter, because that's what I got. I know some of you are going to use the 9 centimeter because in the first question they said, in the previous question we said round it off to the whole number. Now in this case, I'm going to, if I add everything in there, I'm going to get 26.40 centimeters. Please, it's not centimeter squared because it's perimeter. We're just adding the sides. So it's centimeter, centimeter, centimeter. We're adding centimeter. I know with some then you're thinking, we've got 3 centimeters, then you must put cubic. No, the cubic is volume, square is area, perimeter is that unit that you're using there. So the perimeter of the shaded area will be 26.48. Okay, so must understand the word perimeter, must understand the word area, must understand the word volume. So if you know those 3, you'll be able to do questions like this. Okay. Now the next one says calculate the area. You see now, I need the area. I need the area of this part. I no longer need the perimeter, I need the area. So remember the formula for the area. So the area for a figure like that, I will need the RS over 2, or the other formula can be A equals to R squared theta all over 2. So I can use any of those formula. But I must know how to use it. So in this case, I'm going to first use this formula. So my radius here is going to be 9. Do you remember what is my arc length? Remember the arc length that we got there was 8,48. So I can use that arc length, which is 8,48, all divided by 2. Now, if I multiply this 9 multiplied by 8,48 and I divide it by 2, my answer becomes 38, and now look at the question. It says 1 decimal place. So that will be 38,2. Remember its area, so it must be centimeter squared. Now area, it's squared. Remember the perimeter was not squared. So now in this other solution, I can say area equals to the R squared is 9 squared. But remember I already have the angle in radians. So my angle was 0,94 and some values there. Remember, I must use all the values. So that I get approximately the same answer that I got there. So if I multiply all this, I get 38,2 square centimeters. Okay, so if I use the formula where the S, if I don't have the S, then I'm going to use the formula which has an angle. Otherwise, you're either going to be given the angle or you're going to be given the arc length, or maybe in the previous question you will have calculated the arc length. You can use that arc length there. The most reliable one where you don't have where you're not going to make mistake is the second one. Reason, the angle is given, the radius is given, just change the angle to radians and then you can do it. Sometimes you'll have made a mistake in finding the value of the arc length, then you take that mistake into that other question, then you'll lose some marks. Okay, right. So the safest one is to use everything that has been given on the diagram. Okay. Now here is also very nice question in there. The picture shows a spanner being used to tighten the bolt. Here's a spanner, there's the bolt there. So tighten the bolt by rotating it clockwise, in the clockwise direction from point A to point B. So from here to there, they're tightening this one from point A to point B. So this guy is tightening this from point A to point B in clockwise direction. Clockwise meaning he's going that direction. The diagram next to the picture represents the rotation of the spanner. Point O is the center of the bolt, so it's the center of the bolt. It's also the center of the rotation of the spanner. So OA is the distance from the center of the bolt to the end of the spanner. So reflex angle. So in other words, they're saying this reflex angle. So you must know these terminologies, you know. Reflex angle, done it in grade 8, in grade 7, and grade 6. So your reflex angle there, it's given as 29. Can you see it's 29 over 18 pi? So if it's given as pi, therefore you already know that it's given in radians, right? Now, an OC is perpendicular to that. So given that that angle is 90 degrees, the arc length is given. Here is the arc length. So in other words, the length of this one here is 7 pi centimeters. Remember its length. Now they say write down in radians the size of AOB. So AOB, that acute. Now they want this angle here. This is what they want. The acute angle here, right? So remember, acute angle less than 90 degrees. So they need that angle AOB. So I need to calculate the angle AOB. Remember, this has rotated 29 over 18 pi. So for it to rotate throughout this whole circle, for that spanner to rotate throughout the whole circle, so it must be 2 pi. So in other words, for the whole circle it will be 2 pi. But I know part, which is 29 over 18 pi. So for me to get the acute angle AOB, I must take the 2 pi and subtract that part. So if I subtract this part here, I'll be left with this one, right? So 2 pi minus 29 over 18 pi. You can use your calculators for to do that. And the answer that I think you'll get is 7 over 18 pi. Or you can write it as 1,22 radians. So remember, we want it in radians. They said they want it in radians, not in degrees. So it's 7 over 18 pi or 1,22 radians. So that angle here that we are having here, it's 7 over 18 pi. So if I add this angle 7 over 18 pi and I add it to 29 over 18 pi, the answer that I'm going to get there will be 2 pi. Okay, and the 2 pi, remember, is 360 degrees, so it forms the whole circle. Okay, right. Then the next question says hence. So obviously you're going to use what you got in A. So we've got AOB, now we want it in degrees. So in other words, what do we want? We want 7 over 18 pi and we want it in degrees. So if I want it in degrees, what do? I want to eliminate pi. So I just divide this by pi, multiply by 1, on top there I put 1/8. Can you see how many times this question comes? The conversions is very important. So 7 over 18 pi multiplied by 180 degrees divided by pi, and the answer that I'm going to get there is 70 degrees. So meaning that this angle here is 70 degrees. And remember, it's an acute angle, so it can be 70 degrees. Okay, right. Now, the next question, C, it says, let's get the length of OA. What is OA? OA is a radius. Do I know this angle? Yes, I know it. It's 70 degrees. I got it. Do I know this length here? Yes, it's 7 pi. Now they want the length of OA. How am I going to get the length of OA, which is the radius? So for me to get the radius when I know the arc length, I can simply use the formula S equals to R theta. So I know the length there is 7 pi. I don't know what is R. I know the angle is 70 degrees, but remember this angle must be represented as radians, which means if it's represented as a radian, so it becomes 7 pi over 18. Remember, we have done it previously. It's 70 degrees, so we take the 70 degrees and then we use it, we change it to radians. Then we will say my R value will be 7 pi divided by 7 pi over 18. So if I use my calculator there, my radius is going to be 18 centimeters. Right? So I know that R there will be 18 centimeters. That's the length of OA. So I can just write there because that's what I've been asked to write the length of OA. Right? I know it's a radius, so I can just write R. D says calculate the area of the major segment. Remember this one here, it's a minor segment. Sector, I mean, sorry. So this one is a minor sector. Right? So this part here is a minor sector. Now this part here is the major sector. So I need to find the area of this one. Obviously, I must use this angle on the side here. I must use that angle there. So the angle that I'm going to use now is going to be my theta in radians. It's going to be 29 pi over 18. This is in radians. So what do I need? I need the area. So what the area is going to be, how am I going to get the area? I want to use the angle here. I want to use the angle because I don't know what is my arc length of that major one. So I'm going to use the area. So the angle. So if I use the angle, what is my radius? My radius is going to be 18. I already got my radius. My angle is going to be 29 pi over 18. Everything is divided by 2. Right. If I take my calculator and say 18 squared, open bracket 29 pi over 18, all divided by 2, the answer that I'm going to get is 261 pi. Or I can write it in decimals, so they have 90 centimeters squared. Remember, it is area, it must be squared. The units there were centimeters, so I'm going to write it there. So the area of that whole thing there will be 261 pi. Okay, right. Still on the circles and angles. Remember, we're having circles here, and then we're also doing the angles and the arcs. This is quite an interesting question also. And I just love this question. It's a very nice question. Below is the diagram, not drawn to scale, of 2 pulleys. So you can see pulley number 1, and then I've got pulley number 2 there. So in this case, it's pulley 2 and pulley 1. The pulley 1 is a smaller one. Pulley 2 is a bigger one. With a belt connecting the two. So there's a belt here. Can you see the belt here? It's connecting the 2 pulleys. Now, MR is given. So M is from this point to this point. It's 100 centimeters. TS is 220 centimeters. And they say TS and PQ are the same, are equal. So this one is also 220 centimeters. So the length of this belt from here to there is 220, and the length of this belt from here to there is 220 centimeters. But this belt here is 100. So remember, I'm working on the sketch first to understand what to understand that information that is given there. TOC is 110. TOC is 110 degrees. This line here is parallel to that line. Then pulley 1 has a diameter of 30. So meaning that the diameter of 30, the diameter is 30. Which means that my radius will be 15. Very important, that question. The pulley 2 has a diameter of 50, so this one is a diameter of 50, which means that my radius is going to be 25 centimeters. Right, so We must understand that. That's the trick there. So now calculate the magnitude of SCR. So SCR, magnitude. In other words, I need the angle here. Right? If this line here is parallel to that, that means that that angle here that is formed there, plus this angle here will give me 180. And they didn't ask us for the reason. So we don't need to give a reason. But let us talk to the reason. The reason there of this angle and that angle here is that they are co-interior angles. So the sum of the two angles must give us 180. So which means 110 plus this angle must give us 180. So angle SCR will be 70 degrees. As simple as that. So that angle here is 110. This is 70. So this must give us 180 degrees. Okay. So the co-interior angles must give us. Now, the other thing here is that at the point of contact, remember this belt up to here, that angle that is formed there will be 90 degrees. That line is a tangent to the radius. Remember in Euclidean geometry. Because this belt here, from here it goes down, you see. So it goes there. So that angle that is formed there will be 90 degrees. So at the point of contact, every time that angle there will be 90 degrees. Okay. So if these two angles are 90 and 90, 90 plus 90 is 180. So which means that that line will also be parallel to that. So this is 110. So that angle also will be how much? 70 degrees. Right. Okay, so it's 90 plus 90 is 180. 110 plus 70 is 180. 180 plus 180 is 360. So there's a four-sided figure. You get all those angles in there. All right. Obviously, it will be the same principle with this one and that one also. It will be the same principle. So we got the angle there, it's 70 degrees. Okay. Once I've explained the whole diagram, now we know we can then do all the questions. There we've got the 70 degrees and we've got the 70 degrees there. Okay, so we've got the 220, we've got the 220. All right. Now it says, determine the length between the two centers of the pulleys. So we need the center and the center. I need the whole length here. Oh, easy. Okay, what do we do? So the length of the pulleys will be, obviously from here to there we said it's 15. From M to R is given as 100. From R to C will be given as 25 because we're taking the radius now. So in this case it's 140. So we've got 140 centimeters. That's the length of it. Okay. 70 to radians, same principle. 70 degrees to radians. I want to eliminate the angles. I need the pi. So I just multiply out. And I think the answer there should be 7/18 pi. Or we can write this as 1.22. I think we did it somewhere in one of the questions there. Okay. So you can see the conversions are very, 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 very important. Right? D. Now they say calculate the reflex angle QS. You see, that angle we know it's 70. That we know it's 70. They need the reflex angle. Can you see the ways that I use there? Very, very important that you also understand the terminology. Reflex angle. Angle which is more than 180 degrees. Okay. Now, if this angle here is 360, for me to get only this part here, I'll remove 140. So I'll say 140. Now remember they said QS, the length of QS, okay, of the length of QS there. So that length here, can you see? Right. Of an arc length QS, if S SCR and RCQ are equal. So those angles are equal. So we are sure of that. So I've already done it anyway. So now what is the reflex angle? What will be the value of that reflex angle? So the reflex angle, which is QCS, will be 360 degrees minus the 140 degrees, and that angle that is we're going to get is 220 degrees, meaning that the angle from here to there will be 220. If you add it to 70 and 70, you get 360 degrees. That's all that you need. All right. Now, calculate QS. Now, we already know that this one is 220 degrees. Now we need QS, the arc length of QS. You'll see what this question is going to. What is the arc length of QS? So I use the formula S equals to R theta. The theta will be in radians. Now, what is R? What is the value of R in this case? We know that the radius of this one is 25. The theta that we need there will be, remember, theta on that angle will be 11 over 9 pi. So what do? I take the 220 degrees, and then from there I change it to radians. So if I take 220 degrees, multiply by, so I want to remove the angles, I need the radians. So if I multiply out this, I get 11 over 9 pi. And then I'm going to multiply this, and I'm going to get 95.99. And this is in centimeters. So my arc length, so from here, right round to here, it's 95.99 centimeters. Okay. All right. Then the next question says calculate the total length of the belt. Wow. That should be easy now, because I have this one given as 220 centimeters. 220 centimeters. Remember, this is the belt. So the belt comes here, from there it goes around, then it comes there, then it goes around the pulley. So to calculate that, I already have 220. I have this one, the length from here to there, it's 95.99 centimeters. Okay, the only part that I don't have is this one, so I don't have this part. If I've got this part, then I add all the length and I get the length of the belt. Okay, so which means I now need this angle here. So this angle here will be 200 and this is 220, so that should be 140. So I need the arc length. I know the radius there, it's 15 centimeters. So I'm going to say the arc length of pulley 1. I need it because I know arc length of pulley 2. So it's going to be R theta. My R is 15. My radius is going to be 140 degrees. Multiply by pi over 180. Remember, I want it in radians. So if I calculate that, I get 36.65 centimeters. If I use my calculator in there, I get 36.565. So this is the arc length of pulley 1. But what do I need? I need the total length of the belt. So what should I add? This side I know, so this side I know it's 36.65. Now the total length of the belt will be this side, which is 36.65 plus the 220 plus the 95.99 plus the 220. So all this in centimeters. So I can then add everything. So the total belt, if I add this and that 99.99 plus 220, so I've added 4 parts here. The arc length, the part of the belt, the part of the belt there, the part of the belt here, the part of the belt there. So I've got 4 parts here. And if I add all this, I get 572.64 centimeters. So I add all this up. And this question is a very nice question. Then you definitely need to understand. One of the things that you must understand is your Euclidean geometry, because we have used it to get that angle. We have also used it to get that angle, the 90 degrees and all that. We have used it to get this angle, sum of angles around the point. So we've used the Euclidean geometry. So please make sure that you understand all this, because they also integrated into this question. Okay. Right. Just in another easy question that we looked at. This side here is the arc length. The angle is the central angle there. This is the radius, meaning that the radius, that those two lines are the same. So this side is going to be 3 meters. That side is 5 meters. This side is 3 meters. So we need that side here. So you can see the first question says calculate the length of DE. You see, DE is the arc length. So it means that I'm going to use the formula for the arc length. So what is my R there? Is going to be 3 meters. The theta there is going to be 60 degrees times pi over 180. Remember, I must always write my angle in radians. So if I do that, then the answer that I'm going to get there, I think it's going to be pi. So the answer will be pi. Or I can write this 3,14. So in other words, the length of that line there is 3,14 meters. All right. Now the next question will be find the perimeter. You can see they like this question. Find the perimeter. What do I know? This is 5 meters. This is 3 meters. But am I going to calculate this part? No. This is 3 meters. This is 3,14 meters. So I'm not going to calculate this part. Remember, I need the perimeter, the outside, you know, the outside part of that figure is my perimeter. So what should I add for my perimeter here? So I must add 5 meters plus 3,14 meters plus 3 meters plus 5 meters. So I'm going to add all those. So I've added 5 meters, so it's 10, that's 16, and that's 19, so it's going to be 19,14 meters, not square meters. Perimeter, the length, so it's the length of that whole. So maybe I want to put a fence around that, so I just put a fence around the whole thing. You can see that one is in dotted lines, so I'm not going to bother myself with that line. That's why I've cancelled it there. So the perimeter will be 19.14. Okay. Now C says we must calculate the area of the sector. In other words, maybe I want to tile this part here only. So the area of the sector, how am I going to get the area of the sector? I already know. I can use this because I already know what is my arc length, which is 3,14. So I'll say my R value is going to be 3. My arc length is pi, or 3.14, all divided by 2. So the answer can be 3 over 2 pi. Or I can write my answer is 4,71. Remember, it's square meters. So even there, it's square meters. So remember, it's area. So I need the area of this part, which is square meters. So that part here, I can be able to get it. Okay. Right. Now, that D wants us. Now, these are some of the questions that really need you to think a bit, you know, just a bit. Okay. Because now it talks about, I want to tile the whole workshop floor. So in other words, I want to tile everything in there. I want to tile this place, right? But I've got two parts here. I've got part 1, I've got part 2 here. Part 2 will be my rectangle. Let me see. Part 1, it will be my sector, this one, the area of that. Do I know the area of CDE? Yes, I already got it in the last one. So the area of CDE, I have it. So what do I need? I need the area of this part here, part 2, so that I can add it to the area of that one. Then I can then check how am I going to get the amount there. So first I'm going to get the area of the rectangle, which is going to be my length multiplied by breadth, and that gives me 5 meters times 3 meters, and that will give me 15 square meters. Right. But I know the area of this part here. So the area of this part 1, plus the area of, the area of the floor, the whole floor will be 15 square meters, plus the area of this part, which I got was 4,71, if I'm not mistaken, square meters. So if I check this, the whole thing gives me 19.71 square meters. But now it says the tiles with the labor and the material cost 175 per square meter. So how many square meters do I have? I have 19.71 square meters, which means that I need to take that money, which is 175 per square meter, multiplied by the total area. So for me to get the cost of tiling that whole thing, what do I need? I need the total area of the floor. So this is the total area of the floor. I need the total area of the floor. I must multiply it with the cost per square meter, because this one is square meters. So I multiply it with the cost. So the cost is 175 per square meter. So remember, this is meter squared and this one is per square meter. So the meter squared and the meter squared will cancel out. Okay, right. So then I'm going to be left with an amount. So that amount is 3,449.25. So for me to tile that whole area, I need 3,449.25, because I've got 19 square meters. 19 square meters with that amount, I think that's a bit reasonable for that amount to tile the whole floor. Okay, we're going to take a break, a 2 minutes break, and then we'll continue after this. Okay, welcome back. Let's move on. Now, the next subtopic that we do in this chapter, it's the angular movement. Right. Now, first of all, things that you need to know, important notes that you need to know under this one. It's converting using the metric system. Remember, when you convert using the metric system, that's where you change your centimeters to meters, your meters to centimeters to kilometers using your metric system, millimeters to decimeters or whatever. So we really need to understand this also. Again, we also need to understand how to change from seconds to minutes, from minutes to seconds, and to hours, and all that. Very, very, very important. So, and this is what we have done in grade 10, how to change this. Even in the lower grades, we have done that. But in grade 10, technical maths, we have a topic where you have to convert using the metric system. The angular velocity measures the velocity at the center of the turning wheel or a disc. So in other words, at the center, when we have a wheel turning, so at the center, we measure that velocity at the center. It is the measure of how fast the wheel or the disc is turning, but we do it at the center of them. That is the angular velocity, which is denoted by the, that formula, the omega n, because then what we need is just the movement of that, which is 180 degrees, and the number of revolutions. That's what we need. Then we calculate the angular velocity. The circumferential velocity, which is sometimes called this, is the speed at which this wheel it's moving. Okay, right. Now, the formula to be used, I've already talked about the formula that we need to use for the angular velocity. The other formula will be that one, so we must also know this one. It is not there in the formula sheet. Please make sure that you also understand this, where you'll be given the time and also the angle, so you can be able to do that. Remember, the angle will be in radians per minute. All right. For circumferential velocity, we use that formula which is there in the formula sheet. The D stands for the diameter, and the N stands for the number of revolutions, right? If the radius is given, sometimes we use that formula V. It is not there in a formula sheet, where we use the angular velocity and the radius. If the angular velocity is given, we can use that formula. If the radius is given, it must be multiplied by 2, as the diameter is twice the radius. So important notes that you need to understand there. To convert revolutions per minute to revolutions per second, we divide by 60. Remember that. If we want the revolutions per second to minutes, then we multiply. It's very, very, very important also to know that. Now let's look at this question here. It says, the roller in a printer rotates at 2,200 reps per minute. You can see it is written per minute. But look at the question here. It says, determine the angular velocity in radians per second. So meaning that minute there must be changed to 2 seconds. Okay, now how do we do that? First, we must change that one to seconds. So I'm going to say my revolutions, which is n, is going to be changed to, so the n is going to be changed to that. So it's 2,200 divided by 60. Okay, the minutes, right? So therefore, I'm going to get, I think the answer there will be 36,67. Right. So now I'm going to use the formula for the angular velocity, which is 2 pi n. So I substitute the n only in there. Don't substitute the pi. Just leave the pi as it is. Then the number of revolutions there will now be 36.67. Now it is in seconds. So that will be 230.38. Remember, it's radians per second. So that one in radians per second. So that's how we do that part. Okay. All right. And now the angular velocity and that. Question number 2. Now it says the peripheral velocity. Now we said this word here is the same as the circumferential velocity, right? So the circumferential velocity of a wheel, diameter is given in meters. Okay, it's 1,5. And they say that thing there's 55,4 kilometers per hour. So now we want to calculate the rotational frequency of the wheel in revolutions per minute. Okay, so now what am I going to do here? So now I'm going to then take the velocity. So I'm going to say 55,4 multiplied by 8,000. Right. Why multiply by 8,000? Because from millimeters, remember, I'm from meters to kilometers is 1,000, right? So I'm going to multiply that by 1,000. But for the minutes, because I need the minutes here, then I'm going to multiply that one by 60. Well, divide that one by 60. So I've got meters and minutes, right? Meters and minutes, yes. So the answer that I'm going to get there will be 923,33. Remember, I need the rotational frequency. Here I'm just trying to convert. Right. So now I'm going to use that formula. Now it's going to be, because the velocity was given there, I wanted to change it to meters per minute, because that's what I want there. So I'm going to then write down the formula, pi dn. The V is given. Now I got the V to be 923.33. It's equals to pi. My diameter now is in meters. So this is in meters again per minute. So then I need my n, which I don't have in this case. So for me to get an n, I'll have 923.33 all divided by pi into 1,5. Then I'm going to have 923.33. Remember the question they said in per minute. So 923.33 divided by pi times 1,5, and the n value will be 195.94. And this is revs per minute. So I need the revs per minute. I don't need it per second. If I needed it per second, I would have divided that by 360, so that I can take it to minutes, to seconds. Okay. So please read the question. Read the question and what they want. So if they want it per second, then you must do it per second. If they want it per kilometer, you must do it per kilometer. If they want it per meters, then you must do it in meters. Okay. Number 3 had a long story. And this is where we have challenges, because once we see the question with a very long story, and then from there we give up, and not realizing that, you know, this is just a story about those two gear discs, and explaining how they're rotating and all that. Now we're going to work with the numbers. That's what we need. We need the numbers. So the gear system of a bicycle consists of the 2 gear discs and a chain. So I've got a chain here. These are the discs. The pedals of the bicycle are connected to the bigger disc. So that is the bigger disc here, the smaller disc. The schematic drawing of the bigger disc is shown below. So this one is the bigger disc. So it's this one. So this one is that. Right? The radius of the disc is 8. So here's the radius. So this is what we're interested in now, the radius. This is 22 centimeters. The radius is also 8 centimeters. The height is 8 centimeters, 2.5 centimeters. Now what do I need here? I need the the disk turns so that the point A moves to point B. All right, point A, you see, the disk turns so that point A meets point B. Use this formula. See, in this case, they're given the formula. No problem. Use this formula to calculate the size of this in degrees. What did I say about the theta? It's in radians. So what do? You use the formula. So S equals to R theta. S, it's 22, is the length of this line, is an arc length. I need this angle here. The R, it's 8 multiplied by theta. So what do I get? Theta, it's 22 over 8. Right? So now, but we need it in degrees. This is not in degrees. Remember, theta is represented in radians. So 22 over 8 is radians. So if I need theta in degrees, I'm going to say 22 over 8 multiply by, I need it in degrees. So if I need something in degrees, the degrees must be on top and the pi must be below. Okay, then I multiply out that. So the degree that I'm going to get is 157,6 degrees. So that angle here in degrees is 157,6 degrees, and that's what I have. Okay, so remember, every time you know, if I'm calculating that theta is in radians. Then I need to change it to degrees. Changing it to degrees, remember the degrees must be on top, the pi must be at the bottom. So that is the angle that I'm going to get. Right. Now, B says, calculate the area of the smaller sector AOB. So this is O here, right? So AOB, so the angle is given in radians here. If you can take this and take 22 divided by 8, this is what is going to, this is what you're going to get. You're going to get 0.876 pi. If I take 22 divided by 8, that is the answer that I'm going to get. Now it means that that angle that is formed here, it's 0.876 pi. Or if you take 157,6 and then you change it to radians, this is what you're going to get. Now, what do I need? I need the area. So remember, the area is RS over 2. Why am I using S? Because I can see I've got the 22 in there. Right? So I'm going to get 8, which is the radius, multiply by, or let me use the R squared theta, because this is what is given now for me. So R squared theta is 8 squared. Then I'm going to have 0.876 pi and divide this by 2. So my area that is I'm going to get is 88.07 square centimeters. And that is what I'm going to get for that. Okay. C, Roman figure 1 says, now this engineer wants to determine the length of the chord CD. I need the length of chord CD here. Now first I must write down the length of the diameter. So obviously my radius is going to be 8. Radius is 8. If I extend it, I've got 2 radii. Then I've got 8 plus 8. So the length of the diameter will be 2 times the radius, which is 2 times 8, and it's 16 centimeters. All right. Now, determine the length of CD. The length of CD. What is that CD? I have a height here. I have CD. I have a diameter. Oh, can you see? You go to your formula sheet. What is this CD? It's a chord. I have a diameter. I have a height. So what am I looking for? The chord. Which formula must I use? 4h squared minus 4dh plus x squared equals to 0. Then I just substitute. My height is 2,5 squared. My d is 16. My h is 2,5. My x squared is x squared because I don't know it's my CD, length of CD, which is the chord. Remember, x is the length of the chord. So if I manipulate that, I'll get x squared is equals to 135, right? So the x value will be equals to square root of that, it's 11,49. So therefore, the length of CD is 11,49. So from here to there, it's 11,49. This one is the diameter, it's 16, so it makes sense. My answer makes sense. The diameter, the length, the radius is 8, so my answer will make sense then. If my answer was more than 16, then I'll know, oh, there's something wrong, because the chord can never be longer than the diameter. Okay, right. Okay, so D, very, very, very important question also. The disk turns at an angular velocity, so meaning that that omega is given, it's equals to that value. So calculate the rotational frequency of the disk. So you can see that this omega is given. The formula is 2 pi n. What they're looking for is the value of n, rotational frequency. That's the value of n. Sometimes you find that the formula is 2 pi f, and the f stands for the frequency, so which is the same as the rotational velocity. You find when you Google, then you find that the formula for the omega is 2 pi f is the same as the 2 pi n. Right, so now how am I going to get the n here? So I'm going to say this is given 2 pi n, that's what I want. So I need the n. So it's going to be 17,9 all divided by 2 pi, and the n value will be equals to, calculator, 2,8 revolutions per second. Okay, so the number of rotations will be at 2.8 revs per second, because that will be given as seconds. Right, no need to convert there. Okay. Now Roman figure 2 says, now the circumferential velocity of the disk in kilometers per hour. You see now, in kilometers per hour. So the diameter, I'm not going to use the formula where you're going to use the diameter, because they already gave me the angular velocity. So which means that my circumferential velocity will be the omega multiplied by r. Okay, that's the formula. That formula is not there in the formula sheet, but we must always be able to do. We must know this formula. Okay, so it's the omega multiplied by r. So when I'm given the angular velocity, I know the radius, so I can be able to do that. Remember, my radius in this case it's given as centimeters. So I want to change that to, I need to change this to kilometers. All right, I'll see what I'm going to do now. So now I'm going to say this is 17,6 multiplied by 8. Okay, so if I want to change this, I'm multiplying by 8. So now I'm going to have my answer as 140,8. Remember, this is in centimeters per second. Okay, I'm just going to write the centimeters per second. Remember, this one is in seconds, that one is centimeters, so it's centimeters per second. Now remember, they want it in kilometers per hour. So what do I do with my answer? So I'm going to say that's 140.8, which is the same as in per second. I'm going to multiply this by 3,600, because I want to take it to hours. So, and then divide this by, because I've got centimeters there, I want to take my centimeters to kilometers. So from centimeters to kilometers is 100,000. So if I use my calculator there, so you need to understand that. So I need to have, remember the seconds, and the seconds will cancel out, the centimeters will change to kilometers. So I'm going to have 5,06 kilometers per hour. Okay, so I've just changed that to kilometers per hour. The conversions is very, very, very important. You must learn your conversions from grade 10. Go back and learn your conversions. They're very important, because if you leave your answer there, I don't think you'll get 2 marks for that. And then maybe that question was 4 marks, because we've got 2 conversions to do. So please make sure that you also know how to convert. All right. Okay. Now, the last question is a question that comes also every year, and we are really struggling to get full marks on this question. I think this year we're going to do much better on this question after we have done these activities. Now, the picture below shows the partially painted. So in other words, that part is partially painted. The painted area, can you see this person painted only that part? And has got a breadth. So in other words, from here to there, the length of the whole wall from here to there, it's 4 meters. Then it says, the diagram represent the situation above. The height of the unpainted part of the wall is divided into 4 equal parts. So you see it's part 1, part 2, part 3, part 4. Right. And then 1,5 meter long, as shown in the diagram. So in other words, from here it's 1,5, from here it's 1,5, from here it's 1,5, from here it's 1,5. Now they say determine the height of the wall. So in other words, determine the height of the wall. Remember, this is a wall. So the height of the wall. So if this part is 1.5, how many parts do we have? So 4. So it will be 1,5 meters multiplied by 4, which is going to be the height of the wall. So the height of the wall will be 6 meters. If I take 1.5 and I multiply by 4, I get 6 meters. Remember, it's just the height of the wall. The breadth of the wall, it's 4 meters. Okay, so that. Now the next question says calculate the area of the painted. So we need the area of this painted. That's why we use that formula, the area of the irregular polygon, by using the mid-ordinate rule, you see? Okay, so in other words, we can use the mid-ordinate rule of O1 plus O2 divided by 2, O2 plus O3 divided by 2, just like that. Okay, but you can still use this other one, which I almost prefer, which is going to be A, and then into O1 plus ON divided by 2, then will be O2, O1, O2 plus O3, plus O4, and then we can close the bracket. As I can see, we only have 4 of them, 4 of those. All right, so the A value is going to be 1,5. Then we take the first part, there will be 1,5, the top one, plus the last one, which is 2,7. Divide this by 2. Then we add the rest. 2,1, 2,4, and 2,8. Then we close the bracket. Then we just use our calculator. Then please don't calculate the ones in the bracket first, and then from there you then multiply by 4. Just use a calculator at once, so that then you go to the answer. The answer there, I think, is 14,1 square meters. Remember, this is in meters, so it will be square meters. Okay, right. You can use the other formula, you still get the same answer, and I want you to go and use it on this one. Use the other formula, and then you get the other answer. Now, the last part of the question is a bit of a challenge here, right? Now it says a 1 liter tin of paint, which is sufficient to cover the area of this, cost that amount. Determine whether the minimum cost of the paint required to paint will exceed 600. In other words, the answer that you must get must be more than 600. Okay, first of all, I need the whole area of the hole. That is the first thing that I need. So the area of the whole wall, it's going to be 6 meters multiplied by 4 meters. And that gives me 24 square meters. So that is the area of the whole wall. But now what do I need? I need to paint the remaining section. In other words, this part here that is not painted, I want to paint that part. So now I'm going to do what? I'm going to subtract. So I need the area of the unpainted. So I'm going to say 24 square meters multiplied by minus the area of the painted, which then gives me 9,9 square meters. So this is the area of the unpainted. So the area of the unpainted will be 9,9 square meters. All right. Now, what is it that I want? I want how much paint is needed. Paint needed. So I'll take the 9,9 square meters because they say 1 liter cover the area of this. So which means that this must be divided by 3,26 square meters. Because I need the number of tins that I'll get for the paint. So that gives me, I think it's 3,04 tins. But I can have, remember, they say the paint is only sold in 1 liter tins. So if I buy 3 liters, I will not be able to finish my wall because I'll need the 0,4. So better buy 4 tins and then I can be left with some. So obviously that will be approximately how many? 4 tins of paint. Right. But that 1 liter costs 156.36. So what do? I need the cost. So the cost will be 4 multiplied by 156.36. And if I multiply this, I get 625.44. And that amount, if I look at that amount, it exceeds the 600 that I have in my pocket. I need 25 rand 0.44 more for me to be able to can paint that area which is not painted. Okay, so these are basic questions that you're going to be getting, and then please make sure that you understand the whole question and what it wants, and then if you do more of this, you'll be able to can answer this type of questions because they're not very challenging. It's division, multiplication, you know, we're just adding and multiplying and dividing and all that. Okay, lastly, just the tips of solving these problems. Read the problem, take time to identify the certain elements to create a plan to solve the problem. That's what I was saying now. Visualize the problem, try to visualize the problem and use the picture which is given in the problem. Identify what are the requirements to solve. In other words, the formula to choose. Do I need any conversions? Which circle theorems, like I've said, Euclidean geometry is included. How many steps are there for that problem? If it's 5 marks, I need about 4 steps. If it's 2 marks, I need 1 or 2 steps. Use the previous knowledge to solve the problem. Take time to consider if you have encountered a similar problem in the past that you have used. In other words, if you do more, then you will see some of the problems are just the same. By visualizing the tactic work in the past, you can also be able to do the problem. Right, in that, I'd like to say thank you so much for watching, and go and practice this topic. It's quite an interesting topic with all the formula given in the formula sheet, you'll be able to can score more marks on this topic. Thank you so much.